This video is the second in a series of worksheets solving basic linear equations. This is number 2. There was also an introduction video on solving basic linear equations that goes over the processes that will be used to solve the equations in this worksheet. So reviewing, when you solve a linear equation, what you do to one side, you always must do to the other side. You're trying to isolate a variable, an unknown. We'll call it usually x here in these exercises, but it could be any letter or any symbol. But we will be using x at this time. And to do this, we will use what I call the reverse order of operations, which is SADMAP. So the order of operations normally are PEMDAS. When you evaluate a mathematical expression, you do parentheses first, then you do exponents, then you do multiplication, division, working from left to right, and finally you do addition, subtraction, working from left to right. But when you solve an equation, you do the opposite. You undo subtraction, addition first, then division, multiplication, last exponents, and parentheses. So we're going to solve here a series of what we call 1- and 2-step equations. So in problem 1 here, I have x minus 4 equals 9, so I want to isolate x all by itself. So to isolate x, I need to get rid of this minus 4. Well, to get rid of minus 4, I will add 4 to both sides. Because what I do to one side, I must do to both sides, and bring down my equal sign. Keep things lined up. Negative 4 or minus 4 plus 4 is 0. Don't need to write anything there. Bring down the x. And 9 plus 4 is 13. So my answer is x equals 13. I'm going to check my answers. So if I plug in 13 for x, 13 minus 4 in fact is 9, so that checks out. Question 2, x is on the right side of the equal sign, but as discussed earlier, by what's called the symmetric property of equality, $15 equals x minus 3. I'm sorry, 15 equals x plus 3 is the same as x plus 3 equals 15. You can swap things around the equal sign, in other words. So I'm just going to leave this as is, and I need to isolate x. So to isolate x, I need to get rid of the plus 3. So to get rid of plus 3, I subtract 3 from both sides. Let's write this over again. So I'm going to subtract 3 from both sides, because to keep the equation in balance, what I do to one side, I must do to the other side. Bring down my equal sign. 15 minus 3 is 12. Bring down the x, and 3 minus 3 is 0. So my answer is 12 equals x, or x equals 12. So then check my answer. Plug in 12 for x, and in fact 12 plus 3 is 15, so the answer checks out. Question 3, x is on the right side. I have 7 equals 4 times x. Well, this is multiplication times x. To undo multiplication, I use division, so I'm going to divide both sides by 4. So I have 7 over 4 equals x, because 4 divided by 4 is 1, or x equals 7 over 4. You could write this as a mixed number by dividing 4 into 7. 4 goes in 7 once. 1 times 4 is 4. 7 minus 4 is 3. So this also can be written as 1 3/4. Question 4, I have 3/7 equals 2. If you remember, to undo the 3/7, we can use the multiply by the reciprocal. So 3/7 x equals 2. Remember, the reciprocal of 3/7 is 7/3, because 3/7 times 7/3 is 21 over 21, which is 1. So what I want to do is I want to get x by itself, or I want to make this 1x. So to make this 1x, I multiply by 7 over 3, both sides. So this is 21 over 21, which is 1, so that's 1x, but 1x is equal to just x. So I have x on the left side, which is what I want. On the right side, I have 7 over 3 times 2. Well, 7 times 7 over 3 times 2 is the same as 7 over 3 times 2 over 1, because 2 is the same as 2 divided by 1. So this is just x equals 7 times 2, which is 14, over 3 times 1, which is 3. So x is 14 over 3. Or you could write it as a mixed number by dividing 3 into 14. 3 goes to 14 4 times. 4 times 3 is 12. Subtract. So this is 4 2/3. So x is 14/3, or x is 4 2/3. And if I want to check my answer here, I'll use the improper fraction, 14/3. I'm going to take 3/7 in the original problem times my 14/3, replace x with 14/3, and that has to equal 2. Well, 14 over 7 can be reduced because 14 divided by 7 is 2. The 3's cancel out, that's 1, so we get 2 equals 2, so our answer checks out. In number 5, I have 4x plus 5 equals 22. This is now a two-step equation. I need to isolate x, but first I undo the addition subtraction using my SAD map. So undo addition subtraction before division or multiplication. So I'm going to subtract 5 from both sides. And I get 4x equals 22 minus 5 is 17. Now I have 4 times x is 17. Undo the multiplication, I use division. So I get x equals 17 over 4. Or write it as a mixed number, I divide 4 into 17. 4 goes to 17 4 times. 4 times 4 is 16. Subtract, you get 1. So this is 4 1/4. And to check my answer, what I'm going to do is I'm going to use the improper fraction. I have 4 times, replace x here with 17 over 4, plus 5 equals 22. Well, 4 divided by 4 is 1. 17 plus 5 is 22, so that checks out. In the last question, I have 6 equals x over 4 minus 5. So this is x divided by 4. And x divided by 4, you could write that as 1/4 x, but let's just leave it as x over 4. So I need to isolate x, so I need to get rid of the minus 5 first, so I add 5 to both sides. So get 11 equals x over 4. So now I have 11 equals x divided by 4. Well, to undo division, I use multiplication, so I'm going to multiply both sides by 4. Because what you do to one side in the equation, you must do to the other side. Otherwise, you get, I want to keep the equation balanced. I don't want it to become like this or this. One side is bigger than the other. So now 4 times 11 is 44. And then multiplying the other side, 4 divided by 4 is 1 times x is x. So x is 44 is our solution. And let's do a check. So 6 minus, replace x with 44. Or 4 minus 5, and that's an equal sign here. So now 44 divided by 4 is 11. 11 minus 5 is 6, so it checks out. And this concludes the video.